some of those Khan Academy questions were not just rectangular prisms. So when I looked up the lesson to have you do, I just typed in surface area of rectangular prisms, and those were the two that came up. And when I looked in them, I guess I just didn't scroll all the way to the bottom. So if you got some that were maybe like cylinders or triangular pyramids, cylinders we're going to go over today, so you'll have a good opportunity to maybe go back and redo Khan Academy if you didn't do well on it yesterday. So today we're going to, again, go over surface area. We're going to be using formulas instead, so you will definitely want to make sure that you have your calculator. Remember that I can't see anything being typed on the side, so if you have a question or a concern or you need me to slow down, you'll have to reach out and ask. Yeah, the pyramids were hard. So what you have to remember about a pyramid, I'll tell you real quick, that the area of a triangle is 1/2 base times height. So if you're looking at well, let me see here. Let me see if I can get something pulled up. Let me share my desktop. Okay, when I open just up a Word document, let's say, and I draw a pyramid. Let's see, pyramids are kind of hard to draw, but there we go, that's not too bad. So you'll notice that on a pyramid there's 4 triangles and then there's the square base or the rectangular base. So you do the area of the rectangle on the bottom, length times width, but then when you do the area of the triangle, remember that it's 1/2 base times height. So 0.5 times whatever the base is times the height of the triangle, which is like from that top vertex down to the middle of the base. And then you could multiply that by 4. The other kind you might have seen yesterday were, let's see. This is called a triangular prism. Let me get some 3D stuff going in there so maybe it looks a little better. Hey, that's pretty good. And this is the same thing. So you have 3 rectangles here. You have a rectangle on this side, you have a rectangle on the back side, and you have a rectangle on the bottom. So that's length times width. And then you just find the area of the 2 triangles and add those in as well. So while we didn't actually cover it, you do know how to find the area of a triangle. 1/2 base times height. So that's what you would do there. Yes, I am talking. Here, leave and rejoin. Okay, so let's get today's notes going. Oops, I already pulled them up. So today is day 2 of discussing surface area, prisms, and we're going to introduce the cylinder today to help. You will want a calculator. We do some things with pi, so you're definitely going to want a calculator today. Remember, there's one on your laptop, you might have one on your phone, or you may have your own handheld calculator. So, remember from yesterday, this is just a review, that surface area of a rectangular prism has 3 sets of equivalent faces. Remember from this image, the blue faces in that net were the top and bottom, the yellow faces are the front and the back, and the red faces are the left and the right. So, there we go. Blue, top and bottom, right, left are red, and the back and front are yellow. So we're going to use this formula that says if you take 2 times the length times width and you add that to 2 times the length times height and you add that to 2 times the width times height, you'll get the surface area of a rectangular prism. So what's important to recognize here about length, width, and height of a rectangular prism is that, so if you look at this yellow side, it's length times height. Okay, so that's here. There are 2 of those. If you look at the red side, it's width, and remember that this is height. So if we do width times height for the red side, then that's here. Then finally that top, the blue piece, would be width, and here's length. So it's really just so So a rectangular prism has three measurements, a length, a width, and a height. And to use the formula, you just take every combination of multiplying two of those together. So length times width and length times height, and then width times height is the last one. So we're going to practice that. Okay, so find the surface area of the prism formed by the net. Remember, we did this one yesterday. So when you're calculating it using the formula, you really can imagine it folded up, or you can remember that length, width, and height are kind of interchangeable depending on how you turn the figure. But if I were to try to draw this rectangular prism, we'll just draw it in here like this. Oops, that back piece wasn't very wide. There we go, that's a little better. There we go. Okay, so it looks to me as if this might be 8, right? I'm going to call this side dimension 12, and then I'm going to call the height 6. So I'm going to say that the 8 is the length, the 12 is the width, and the 6 is the height. So we're just going to plug into this formula. So the surface area is equal to 2 times 8 times 12. That's length times width. I just did that one. Plus 2 times 8 times 6. That's that one. Plus 2 times 12 times 6. And if you go back to look at our work from yesterday, this is basically exactly what we did. I multiplied 8 times 12 was this one, and then 8 times 6 were the light gray ones, and then 12 times 6 was the black ones. So we basically did that yesterday. So in my calculator, 2 times 8 times 12, that's 192, right? Yeah, 192. 2 times 8 times 6, whoops, 2 times 8 times 6 is 96. And 2 times 12 times 6 is 144. So we get our surface area by adding all of those numbers together. 192 plus 96 plus 144. 432, and remember with surface area we're squaring our units. So 432 inches squared. Okay, if there aren't any questions there, I'm going to go ahead and go on to the next one. So here we have surface area of the prism. Find the surface area, and we're going to use the formula. Notice there's no net here, so I don't really have to draw the prism. It's already drawn like I did on the last one, but I am going to label. I'm going to call this one the length, I'm going to call this one the width, and that is the height. And so now you're just plugging in. It's basically every combination of two of those being multiplied together. At some point, we're going to multiply 11 times 5, we're going to multiply 11 times 6, and we're going to multiply 5 times 6. And we're going to multiply each of those numbers by 2 and add them together. So surface area equals, if you want to maybe jot down that prism really quickly, I'll wait just a minute for you to draw it and label it. While I wait, yeah, we'll wait. I'll see if Jessica was able to get back in. Yeah, she is back in. Can you hear Jessica? Maybe not. Oh, yep, she can. Cool. All right, right on. Okay, so surface area, 2 times length times width. Now, some of you might do this in your head. You might know, well, I know that 11 times 5 is already 55, so I'm going to put a 55 there. That's your choice, however you want to do it. Some of you may just work with your calculator and then just do 2 times 11 times 5 in your calculator and just write that number down. You know, it's up to you. I'm going to obviously show all the steps. So 2 times the length times the height, that's 2 times 11 times 6, plus 2 times the width times the height. So then in my calculator, 2 times 11 times 5 is 110. 2 times 11 times 6 is 132. And 5 times 6 is 30, and 30 times 2 is 60. I don't need the calculator for that one. So 110 plus 132 plus 60 is 302. And notice our units here are centimeters squared. Okay, I'll give you a second to copy that down. I think we have one more prism maybe before we go into cylinders. Or nope, we're going to do a cylinder right now. Okay, so let's talk about cylinders. We did volume of a cylinder, and the volume of a cylinder had that funky formula, pi r squared h. We're going to kind of use part of that today, which is nice because we've already worked with that formula. So when you're calculating the surface area of a cylinder, first we have to think about what's a cylinder made of and what would its net look like. So this is really interesting. Most of you would tell me that a cylinder is made up of two circles, right? The top and the bottom. But then the outer, this part that wraps around, this part here that wraps around the cylinder, think about on a soup can, the label of a soup can. This is how I always tell students to kind of visualize this. If you visualized a soup can and you imagined cutting the label vertically, so from the top straight down to the bottom, and then you pull that label off and you open it up, you unwrap it from that cylinder, it actually is a rectangle. That rectangle has, we call it a height here because it technically is the height of the cylinder, but we also call it the width. And its length, how long it is, check this out. Let me come back up here to this picture. Its length, how long that soup can label is the same as this. What is this on the circle that I'm tracing? Does anybody remember? When you go around the outside edge of a circle, what's that called? Anybody? Circumference. And the circumference, remember, is 2 pi r. We used that formula back when we talked about circles. So we can find the surface area of this cylinder by looking at two circles, right? We've got two circles. We need to find their area. We know that. And we have this rectangle shape that's kind of like the soup can label. Imagine that rectangle wrapping around the cylinder. So it's going to be, again, a bunch of areas added together. That's what surface area is. It's the area of all of the surfaces. So a cylinder is two circles and one rectangle. So the rectangle, again, is going to be 2 pi r times h, and the circles are going to be pi r squared, but there are two circles. So that's where that comes from. So there's the formula. I want you to write this one down. The formula for surface area of a cylinder, 2 pi r squared plus 2 pi r h. And it's one of those things where in the grand scheme of things, do you have to absolutely understand why that's the formula? Maybe not necessarily right now. Do you have to be able to use the formula? Absolutely. Okay, we know what r squared means. It means r times r. We know what pi is. We can multiply two different sets of numbers together and then add them. So that's what we'll be doing. 2 pi r squared plus 2 pi r h. Okay, so let's do some practice. Here we have the net of a cylinder, and we're asked to find the surface area to the nearest tenth. Several of you on that quiz last week on volume weren't rounding correctly, so I had to go back into Canvas and make a few adjustments. So if you saw your score change, that's probably why, because I was trying to fix the rounding errors that Canvas didn't acknowledge the same right answer, even though you were really close. Okay, so I'm going to write the formula down. I don't think I have it here. Oh, I do. Cool. Okay, so 2 pi r squared. I'm just going to fill in numbers. That's what we're going to do. 2 times 3.14. And the radius, what is the radius? The radius of the circle. So that will be labeled somewhere. Maybe the radius is labeled, maybe the diameter. In this case, we do have the radius labeled. So that's 4, and I'm going to square it. Then we're going to add 2 times 3.14 times the radius again, now times the height. The height of that cylinder is 6.2 feet. This is a really tall cylinder. Why would we have a cylinder this big? I don't know. Okay, so in your calculators, that's how we're going to crunch these numbers out. And remember that some of you might have a calculator where you can string this whole thing in, and others of you are going to have to do this in 2 different parts. If you're doing it in 2 different parts, you're going to have to round, but I don't want you rounding to the 10th right away, because then we don't get an exact answer. So I'll tell you what I mean. 2 times 3.14 times, remember that 4 squared means 4 times 4. So in my calculator, I just did 2 times 3.14 times 4 times 4, and I get 100.48. Notice I did not round yet. We will round. 2 times 3.14, I'm moving on to the second part, times 4 times 6.2. That's 155.744. Now we're going to add them together, and then we're going to round. So I'm going to write the long answer here. When I add them together, I get 256.224. This is the 10th place. 10th, not tens place. Okay, this is the tens place. We want the 10th. It's the first spot after the decimal. So if I want the 2 to stay, I have to look behind it. If the number behind it is 5 or greater, I round up. It's not. It's a 2. So we're going to keep this 2 a 2. So the answer becomes 256.2 feet squared. Again, it's area, so we're squaring. So it's an ugly formula, right? That's really ugly, but you can plug numbers into a formula and crunch out an answer. I'm confident in that. And that's really what you've got to be able to do in terms of this lesson. If we were actually in school, we would have, like objects. We'd be looking at them and unwrapping them and cutting them so that we could see what they look like folded out. But unfortunately, that just doesn't work as well when we're all sitting at home. So, all right, let's do another one. Find the surface area of the cylinder, and there's your formula. So what you want to make sure is that right away you can identify the radius and the height, because those are 2 numbers that you need. Hopefully, looking at this picture, you can see that 5 is our radius and 10 is the height of the cylinder. So to find the surface area, I'm going to do 2 times 3.14, and I'm going to multiply that times 5 squared. 5 is the radius. The second part, 2 times 3.14 times 5 times 10. Radius times height. So then these are the numbers we're going to try to crunch out in your calculator. 2 times 3.14 times 5 is 157. And I realize that I'm probably punching this stuff in faster than you can, but if you're at least following along and writing this stuff down, you know how I got those numbers, right? I used a calculator. 2 times 3.14 times 5 times 10 is 314. This one's cool. I'm not even going to have to round. So now I'm going to add 157 to 314 to get a total of 471 centimeters squared. Okay, and one more, I think. No, we're done. Cool. Okay, so just real quick, I want to go back to, right here. So just remember that this formula, while you don't necessarily have to understand why is it 2 pi r squared and why is it 2 pi rh, we just want to make sure that right now you're at a place where you can plug these numbers in so that you know how to calculate it by plugging the numbers into the formula. Remember that pi r squared is the area of a circle. And so when you look at a cylinder with its net, you see two circles. That's where this 2 comes from, right? Here's one circle, here's two circles. And they're the same size. They're the top and the bottom of the cylinder. Think about a soup can. The top and bottom of a soup can are identical. Then the area of they call it the lateral surface. That's this part that kind of wraps around, that's the soup can label, or it's the part of your pop can that tells you what kind of pop you're drinking. Even with a pop can, I don't know if any of you have ever done anything with pop cans. There are some really cool things you can build with pop cans. You have to be obviously super careful because pop cans are like razor sharp. But if you get a pop can cut into and you cut straight down it from the top base straight down to the bottom base, that pop can will open up also, and it'll say Mountain Dew. I don't know, what's everybody's favorite pop? Do you guys even drink pop?
Yeah.
You do? My favorite pop is Cherry Coke. That one's my favorite. That's what I always had on Fridays in my fountain pop. On fountain pop Fridays. I miss those. I don't do those anymore either. Whew. Okay, so your homework today, let me go back to that slide. Your homework today is a quizzes activity, and you need to write the code down somewhere. 822286. Lots of twos there. 822286. Okay, let me get out of this. Discard. Close. Don't save.